Today we are doing this word, aren't we, Drew?
Yes.
What's that word?
O.
Exponents. We're going to do exponents, write exponents in your notes. We are eventually going to get to scientific notation, so this will probably be a new concept for some of you. We're just going to introduce it, okay? You don't want to fall some. All right, so let's look at this. Drew, what number is this?
9.
How many times do we have it written?
4.
4 times. So it's not 9 plus 9 plus 9 times plus 9. It's 9 times 9 times 9 times 9. So scientific note or exponents tells us we can write this. We're going to do this 9 4 times, not 9 times 4. 9 times 9 times 9 times 9. So this is 9 to the power of 4. You can get down. Yes. Okay, here we're doing 2 to the power of what, Drew?
3.
3. So we're going to do 2 to the power of 3. Do not do 2 times 3. That's bad. Tell them it's bad.
That's bad.
We're going to do 2 times 2 times 2. 3 times. 2 times 2 is?
3.
4 times 2 is 8. Okay, if you want to write the steps, you can, but we're going to evaluate this. Okay, this is 4 to the power of 4. Drew, is this 4 times 4?
No.
No. Tell them it's bad.
That's bad.
So we're going to do 4 times 4 times 4 times 4. 4 times 4 is 16 times 4 times 4. We could do 16 times 16 as a shortcut, those and those, which is 196. We could do 16 times 4 is 64. 64 times 4. It's not 196. It's not 196. It's 256. Who told you it was 196?
Nobody.
Okay, 256. All right, next, 10 to the power of, Drew?
6.
6. So we could write, there's a shortcut for this, and I'll show it to you here in a second. So we're writing 10 6 times. Now we know anytime we multiply, we can multiply 1 times 1 times 1 times 1 times 1 times 1, and then add all the zeros. How many zeros are up there, Drew? 6. Right, 6 zeros. So I could just, as a shortcut, write the 1, and then 1, 2, 3, 4, 5, 6 zeros. And I can put my commas in. Right? That's 1 million. You would not be able to do that with 20 to the power of 6. But with 10, we could do that. 10 to the power of 6, 1 followed by 6 zeros. And we will use that over here with scientific notation. Right, Drew?
Mm-hmm.
All right, scientific notation. We use this in science a lot. The reason we use this is because in science numbers are really big or really small. Show me really small. Now show me really big. Okay, so we do this so we don't have huge long numbers. We can condense them quite a bit. So first you're going to have a number that's between 1 and 9. Okay, or 9.99999, less than 10. Okay, and then we're going to do times 10 to some power, depending on what it needs to be. Okay, so this one is 7 to the power of 10, 7 times 10 to the power of 6. This is already in scientific notation because it has 7, number between 1 and 10, times 10 to some power, which we know right now, 10 to the power of 6 was this. So 7 times a million is?
7 times a million?
7 times a million is what?
7 million.
7 million, exactly. 7 with 6 zeros after, right? So 6 and 2/10 times 10 to the third power would be 6 with 3 zeros after it. But look what I need to do. We know anytime we multiply by a power of 10, we're moving the decimal over. That's still 6 and 2/10. So I'm going to move the decimal over 3 spots. So I'm not adding 3 zeros because I have that. So it's 6,200. I move the decimal 3 spots times 1,000. All right?
Mm-hmm.
Okay. Now let's go the other way. I'm starting with 5,082. Drew, point where I need my decimal. So it's a number, yeah, right there. We want our decimal right here. So to get our decimal right there, 5.082, 5 and 82 thousandths, I need to do times 10 to the, how many spots did I move the decimal over? 3 times 10 to the 3rd power. That is scientific notation, right?
Yep.
50 and 82 hundredths times 10 to the 2nd power is the same answer. But is that scientific notation?
No.
No, it's not. All right, so that's how we do scientific notation. So this all goes in our notes under exponents. See you guys tomorrow. Say bye.
Bye.